Hi everyone, this is Purnima Mahalingam. In last video, we have seen what is the basics of heating and cooling, why the cooling is needed, and how the heat is produced. And in this video, we are going to see the derivation about heating and cooling. In last class, we have discussed about these how the heat is developed and how the heat is absorbed and disappeared. And in this video, today in this video, we are going to see them how the heat and cooling is disappeared. In last video, we have seen this temperature theta is equal to theta f into 1 minus e power t divided by tau. So this is the final derivation equation we have found the temperature, how the heat is developed, And here, based on this, we can see let us consider the time period of t. That is here that we can consider time period of t, that is tau. Then the temperature the temperature t is theta is equal to theta f into 1 minus e power minus t. So we considering t equal to tau, then what happens is here already we know that theta is equal to theta f 1 minus e power minus t divided by tau. Here now applying t is equal to tau, what happens here? Here what happens? So tau divided by tau cancel and it gets 1. So that 1 is here. That is equal to theta f into 1 minus 1 by e, that is equal to 0.632 theta f, that is 0.632 theta f. Okay. Here similarly we consider t is equal to 2 tau. Now consider tau. Now the temperature t is equal time period t equal to 2 tau. So what happens here? Now we are going to apply 2 tau. So here 2 tau divided by tau, then we are getting the temperature theta is equal to 0.865 theta f. Now if applying theta equal to 3 tau. So theta equal to 3 tau, what happens here? Here now applying theta equal to 3 tau divided by tau. Here the theta, again the theta is equal to time equal to 3 tau, theta equal to 0.95 theta f, 0.95 theta f. And now time period t is equal to 4 tau, 0.094f. Now we are drawing the graph for between the temperature and time period. We are going to draw the graph between the temperature theta and the time period t. We are going to draw graph between temperature theta and for time period t. Okay, let's draw the graph. So here the temperature, this is the temperature. Here this y-axis is the temperature and x-axis is your time. Here at the time when the time is tau, what happened when the temperature is 0.632 theta f. When the time is at a tau time, the temperature is about 0.632 theta f. If the temperature is when the temperature reaches the time period theta is equal to 2 tau, the temperature reaches to 0.865 theta f. When the time period is 5 tau, then the temperature reaches is to 0.99 theta f. When the time period is increases, what happens? The temperature is also increases. So this graph represents the graph between the temperature and the time period. I hope this will be understanding. So next we are going for cooling curve. What is cooling curve? If a machine is switched off or when the load is reduced, the machine is cools. When the machine gets cooled, when the switch off the power or the reduces load, the machine gets cooled. When there is no heat generation, then the heat stored when the no say example, when there is no heat generation, the heat stores in the machines is dissipated to the surrounding. When the no heat generation, what happens? When the whatever the heat inside the machines, it moves out, it comes out from the machines, so dissipate to the surroundings. So here the heat developed plus heat absorbed is equal to heat dissipated. What is the heat developed already inside the machines, and heat what is observed, and then how is equal to heat dissipated. That is the example. Then again the rearrange the equation W dt plus gs d theta is equal to A tau d slab. By solving this, here the cooling temperature equation theta is equal to theta, that is cooling is a 0, O or e power minus t divided. This is the final equation, cooling equation. Theta equal to theta 0, that is theta 0, e power minus t divided by tau dash. So this is the equation, cooling equation. Okay. Here, we're now coming to the same characteristics, heating and cooling curve characteristics. Here again, we are going to draw a graph between the temperature and time period. Here now applying the time period t equal to tau dash. Here we know the formula theta equal to theta 0 into e power minus t divided by tau dash. Now first we are applying the time period t is equal to theta tau. What happens? So theta equal to theta 0 into e power minus 1. That is with the e value. And now we are applying the temperature time period for 2 tau. What happens? The temperature increase. The temperatures gets decreases. Then what happens here? The temperature gets decreases by increasing the time value. Here the graph between the temperature theta and here the time between the temperature theta and the time value t. What happens here? What the heating curve is increases. What happens when with a cooling curve, what happens? It decreases to the normal 0. Here the curve is decreases. Cooling the curve is decreases because here the temperature is decreases by using the value when the temperature, when the time is this is theta. What happens here? The theta tau. What happens? It decreases. The temperature gets decreases. This is the characteristics between heating and cooling curves. So when the heating curves occurs, the temperature gets rises, and the cooling curves, what happens? The temperature gets reduces. This is the characteristics of heating characteristics between the temperature and the time period. So in this video, we have seen what do you mean by heating and cooling, and why the heating, how the heating occurs, and why the cooling is needed, and what is when the heat occurs, what happens? The temperature gets rise, how the temperature gets rises, and what the equation for a heating curve, and next thing is cooling, and we have seen what is cooling, how the cooling occurs, and what is the graph between cooling. I hope in this video you'll be clearly understood what is heating and what is cooling, and what is the graph between the heating and cooling and temperatures based on the time value, how the temperature gets increases and the temperature get decreases. Okay, thank you so much. In next video we can see.